Given a velocity versus time graph, how do we determine the displacement of the object? This is going to be the same thing every single time. What we're going to need to do is we need to find the area between the line and the x-axis. So if that's the case, I have 4 practice problems here. If I'm going from A to C, so that's 0 to 5 seconds, then what I do is I look at where my line's located. The whole line is underneath the x-axis here. Okay, so that means I need to find the area of this figure. Now this figure is a trapezoid, so we can certainly use a trapezoid problem, but I think most people are comfortable with splitting this up into a rectangular shape and a triangle shape. Okay, so we have these 2 shapes here, and to get the displacement, we just need to get the area of both. So the area of a rectangle is just the length times the width, or base times height. So if I take a look here, here I'm at 0 to -6, so the length of this side is -6 meters per second. That's how long this side is. The length of this side is in seconds, and it's 2 seconds long. And so what I end up getting is -6 times 2 is -12, but meters per second times seconds is meters, which makes sense because displacement is a change in position. So this means for this time from 0 to 2 seconds, it means that I moved left 12 meters or south 12 meters. All right, so I have that, but I also need to get the triangle. So this was the rectangle, and I'm going to get the displacement of the triangle. Well, a triangle, the area is 1/2 the base times the height. So here I have 1/2, and if I consider this the base is -6 meters per second, and if this is the height of the triangle, I'm going from 2 to 5 seconds, that's 3 seconds. So this is going to be -9 meters. All right, so if you plug that in your calculator or multiply by hand, 1/2 of -6 is -3, times 3 is -9. So the total displacement from 0 to 5 seconds, so this is the total, it's just going to be the sum of these two, -12 meters plus -9 meters, and so you get -21 meters, which means, like I said, it's 21 meters in the negative direction. So depending on what that is, usually left, down, south, all right, those would all be examples of negative directions, of general negative directions. All right, so from C to F, all right, so this is a bigger figure here. This actually, I think I changed this. This is from 6 to 9 seconds. All right, so this is really from D to E. So let's change that. That should be corrected on your sheet. So from D to E, which is 6 to 9 seconds. So what I'm going to do, here's my 6 seconds. Here's my 9 seconds. So from this line, I'm drawing straight down to the x-axis. Okay, so this is the shape we're looking at. That's a rectangle. So delta x is the length times the width. So if I go from 0 to 6 here, that's going to be a positive 6 meters per second. And then 6 to 9 is 3 seconds. And so the displacement here is positive 18 meters. Okay, so here I was going in the negative direction, so left 21 meters. Here I'd be going right 18 meters. So displacement, remember, it's direction and distance. Okay, so because this is positive, that's the positive direction. All right. From F to G, we have, let's go, this color here. Ooh, actually, let's go this one. 10 to 13 seconds. So let's take a look. Here's 10 seconds, and here's 13 seconds. Now, if you'll notice, I need to color in the area under or above the curve. But notice this is not above the x-axis, it's not below the x-axis. So it turns out here that the displacement is equal to 0 meters, okay? And the reason why is because the velocity during this whole time is the object is at rest. So the object is at rest because the velocity this whole time is 0 meters per second. Okay, so the velocity at 10 is 0, 11 is 0, 12 is 0. Now you don't want to confuse this with D to E. A lot of people think D to E is at rest, but notice the velocity here is 6 meters per second, 6 meters per second, 6 meters per second, all in the positive direction. So here, even though this was a horizontal line, I moved 18 meters. What didn't happen here was my velocity didn't change, but I actually had motion. I was moving during this time from 6 to 9 seconds. So that's why I have displacement. So even though this is also horizontal, I don't have displacement here because I'm actually at rest. I'm not moving during this time. All right, so then the last section here is G to H, and that's going to be a triangle shape. So for this one, it's 1/2 the base times the height. So here I'm going 0 to -6, so -6 meters per second, and then that is for 2 seconds. So my displacement is equal to -6 meters. All right, so this is everything about finding the displacement from a velocity versus time graph. Okay, so what is the graph? Velocity versus time. What are we finding? Displacement. So this is the process for that. You need to make sure that you know how to find the area of a trapezoid. You're more than welcome to split it up into 2 shapes. You need to make sure that you're okay finding the area of a rectangle and an area of a triangle. So make sure you know those formulas. And then also make sure you know how to draw it. So again, finding the displacement. If it's the area between the line and the x-axis, look at your time frame and figure out, well, where is the line during that time? So you can draw a start and an end point. Once you do that, from the line, draw to the x-axis. So here was my line here, so then I had to draw up to the x-axis. So that is displacement. In the next section, we are getting the motion from a velocity versus time graph. So for this one, it says, given the velocity versus time graph, how can you identify when the object is moving in the positive direction? Okay. Now, if I were to take a look at my displacement, notice from 0 to 5, my displacement was in the negative direction. But notice here, my displacement was in the positive direction, okay? Now, in terms of figuring out which way we're moving, all right, it's much easier to consider the velocity. Here, the velocity is -6, -6, -6, -4, -2. I have negative velocities everywhere the graph is underneath the x-axis. And that is why I'm going to have a negative displacement, because I'm moving in the negative direction. And here, the reason why I have a positive displacement is because I'm moving in the positive direction. All my velocity values above the x-axis, all of them are positive values of velocity, which means I'm moving in the positive direction, and I will have a positive displacement. And if I'm on the x-axis, I'm not moving, so I don't have displacement. So over here, moving in the positive direction, all you have to do is look to see when the line is above the x-axis. For negative, the line is below the x-axis. For stopped, the line is on the x-axis. Okay, so just the location of the line tells you the direction that it's moving or if it's not moving at all. So next we need to take a look at, well, when are we maintaining constant velocity? So when is our velocity not changing? Well, that happened twice in this graph. Here I have 6, 6, 6, 6. So I had a velocity of 6 meters per second. Here, from 10 to 13, I had a velocity of 0, 0, 0, 0. What do they have in common? They are both horizontal lines. So horizontal line means that I have constant velocity. Speeding up. Okay, so here for speeding up, I'm at 0, and then I'm at 2, 4, 6, so I'm getting faster and faster here. It turns out I'm moving away from the x-axis. Well, let's see if that works over here. Now here I'm getting -2, -4, -6. It appears because it's negative it's getting smaller, but remember, velocity is just speed with direction. So what's really happening is I'm moving in the negative direction, but I'm going 2 meters per second, 4 meters per second, 6 meters per second. So as I'm moving away from the stopped position, so here velocity is 0. If I'm moving away from 0 meters per second, I have to be getting faster. So we're speeding up when we move away from the x-axis. And then we're slowing down when we move toward the x-axis. So 6, 4, 2, coming to a stop. Here, 6, 4, 2, coming to a stop. So this is when we are moving toward the x-axis. Okay, and then for this last section here, what we're going to do is we are going to mark each section of this graph with these symbols or these two letters. So P for positive direction, and, oh sorry, not P, positive sign for positive direction, and negative sign for negative direction. Well, I can quickly look at my graph and put pluses or minus everywhere I need to. So for example, if I'm moving in the positive direction, these are all of my positive velocity values. So that's going to be everything above the x-axis. Where does that happen? That happens from C to D, D to E, and E to F. These are all positive. They're all above the x-axis. So that is C to D, D to E, and E to F. Okay? C to D, D to E, E to F. Then the negative direction is everything below. When does that happen? A to B, B to C, and G to H. A to B, B to C, and G to H. Okay? And then that's positive, negative, or we would have stopped. Well, we're only stopped when we're on the x-axis. All right, only when we're on the x-axis. So where does that happen? That happens at point C, and it happens from F to G. So we are stopped here, and from F to G, we are stopped. And then constant motion means I'm not getting faster, I'm not getting slower. That's my horizontal line here. So constant motion is D to E. So I'm going to put a C for constant, and it's F to G. So F to G is constant. So we're stopped, but we're also constant. Speeding up is when I'm moving moving away from the x-axis. I'm stopped on the x-axis, so if I'm moving away from it, I have to be increasing in speed. That's C to D, so that's speeding up. And I'm moving away from the x-axis, G to H. So that's speeding up. And then, oh, A to B is constant. I missed that one. So that's constant because it's horizontal. B to C, I'm moving toward the axis, so I'm slowing down to a stop. And then it looks like E to F, I'm moving toward the axis, so I'm slowing to a stop. So that's also slowing.